So the other week I published an article about how I was able to fork auto research and configure it for the specific use case of optimizing a weighting function for portfolio and index composition. So quick TLDR on auto research, like what you need to get it to run properly and like how to set it up. Basically, you start with a goal, a specific measurable metric, and a set of data. You're able to run an agent to optimize for that specific metric. So in the original auto research, Andre Karpathy used this to optimize for the validation loss in language model training. So similarly, I started out with the goal of optimizing the weight function for maximum volatility. This is the opposite of most volatility-based portfolio compositions, so it was a pretty good testing ground for how exactly to set up a discovery process with an agent looping pattern. So yeah, publish this under the Stradium account. I selected an asset universe that's pretty relevant as well to the use cases that we're working on in terms of custom indices. The categories here are the 18 futures or perps available on Hyperliquid that are categorized under DeFi. This is 18 like final selection, but then there was a additional constraint to only select the DeFi category perps that were equal to or above 5x leverage, because that's just a signal that, okay, if there's a high enough leverage multiplier, that must mean that there's adequate depth being supported by like market makers and whatnot. So quickly go over the constraints. There needs to be a minimum of 12 constituents in the index. The direction can only be long, so not a composition where you have like some short positions. And yeah, so contrary to the original auto research implementation, when you're optimizing for validation loss, you're looking for the lowest value. And in this case, since we're optimizing maximum volatility, then the metric we're looking for is higher. So yeah, this article goes more in depth about like which strategies actually won, how I set up the tournament mechanism to have each agent run, basically do like a bracket style experimentation loop where it does a bunch of it throws out a bunch of random strategies first, puts them against each other, and then like chooses one winner. So yeah, gonna be quickly going over how I turned the outputs of the weighting function that was discovered by this agent loop into an Oracle program on Seda. So we can dive into the diagram here first, then I'll show the actual outputs of how the index Oracle feed looks like. So the first thing to keep in mind about how I'm setting this up as an Oracle program is that the agent logic is decoupled and separated by a human in the loop gate. Before actually going into the Oracle, they reach this staging phase where you need to manually approve or reject. So let's say your first run produces the first weight function that you end up using. You can have the agent keep on running in the background to continue staging different versions and basically proposing like, hey, how can we bump up the metric by a little bit? And once you have the function that you know you want to use for the Oracle program, this goes into the pipeline to pretty much just prepare that data to be sent as a request onto the Seda network and deployed on chain. So once the request gets sent out to the Oracle network, this is where the actual pipeline happens for turning it into like its own price feed, where it's fetching the actual prices of the asset universe that we used in the initial research loop from available Pyth data feeds, and calculates the index based on the actual price per asset with the weighting function that was described earlier. And once it's signed on the network, this is the final step before it goes into like any consumer layer. So whether that's a smart contract directly on chain, or in the case I'll be showing here, which is just a admin panel to view like, okay, here's the Oracle program ID, and here's the actual like implementation of a price feed that's based on the asset universe plus the index composition. And you can see the actual composition here. You can see that's following all the constraints of choosing the constituents. And we have the staging panel here ready. So far, I haven't done any additional runs with the agent, so it hasn't proposed changes to the weighting function. But if I were to run that now in the background, they would be showing up here for me to approve or reject. So yeah, the same logic can be applied with whichever use case you're going for. With a Seda oracle, you can apply whatever dynamic logic you want here on your own backend system. And then once you post it to Seda and deploy it, then it can be used in any application. So what this specific index methodology is being used for, as you can see from the article itself, is the HIP3 perps deployment, and more recently HIP4 prediction markets deployment. So HIP4 is actually a pretty good example of where something more experimental like this can be used, because it doesn't rely as heavily as on the formal market making agreements that you need to sustain a proper HIP3 perp, and can be driven more speculatively to see whether or not users or traders are resonating with the synthetic asset. So check out Seda, check out Stradium, and I'll have a link to the repo for the Oracle program in case you want to fork it and try out your own agentic oracles.